Question number 14th says, find the equations of the tangent and normal to the given curves at the indicated points. Okay, this question is pretty interesting, has many parts for that matter, and we are supposed to find the equations of tangent and normal to this curve at this particular point in this case. Right. So for finding the equation of tangents and normals, we are supposed to begin with finding the derivative of this point, right? That's what we'll do. We have y equals x power 4 minus 6x power 3 plus 13x square minus 10x plus 5 at 0, 5. This is what we are interested in. Let's find the derivative. dy by dx. We already know the point, right? Finding the derivative will give us the slope of the tangent, and therefore we can get the equation very easily. dy by dx will be equal to 4x power 3 minus 18x square plus 26x minus 10. This is dy by dx. So let's find at 0, 5. At x equals 0, dy by dx will be equal to what? For x equal to 0, dy by dx will be 0 minus 0 plus 0 minus 10, which is actually minus 10. That's the slope of tangent. Therefore, for tangent, we needed two things. What are the two things? For finding equation of any line, we need two things. Tangent is also a line. We need two things, that is maybe 2 points or a point and a slope, and we have obtained that. 0, 5 is the point and minus 10 is the slope. That's what we have, right? This is the point and this is the slope. On the basis of these two, I can easily find the equation. The equation will be y minus y1 is equal to slope, that is minus 10 times x minus 0. This gives me y minus 5 is equal to minus 10x, or that tells me 10x plus y minus 5 is equal to 0 is this tangent for me. Is that okay? Yes. This is the equation of tangent, as you can see over here. What about the equation of normal? For the normal, the point is already known. The slope can easily be found by taking the negative reciprocal of this. The tangent and the normal are perpendicular to each other. If this slope is m1, this slope is m2, then you know that m2 will be equal to minus 1 upon m1. The product of the slopes is minus 1 if the two lines are perpendicular. That's what you know. So on the basis of this, I can easily comment for normal. For normal, what do I know? I know the point. This is the same point, 0, 5. And I know the slope. Slope is minus 1 upon that slope, which is minus 10. What does that give me? 1 upon 10. This is the slope. Equation will therefore be obtained very easily. Y minus 5 is equal to slope times x minus 0. That's what I'm doing over here. And this will give me 10y minus 50 is equal to x, or that tells me x minus 10y plus 50 is equal to 0. That's the equation of normal that you require for this question over here. And that's all in this question. Second part of this 14th question says that we are given a curve which is, as you can observe, the curve is similar, but the point is different over here. Okay, and we are supposed to find the equation of normal and tangent. Let's begin with finding the derivative. Dy over dx is equal to what? 4x power 3 minus 18x power 2 plus 26x minus 10 is what I have. And we are given point 1, 3. Therefore, at x equal to 1, what will be the value of dy by dx? Dy by dx is equal to 4 times 1 power 3 minus 18 times 1 square plus 26 times 1 minus 10. This is 4, which is okay, pretty simple. This is minus 18 plus 26 minus 10. This is 30 minus 28, which is simply 2. Now that is the slope of derivative, slope of tangent basically. This is the derivative at x equal to 1, therefore this. So for tangent, what do we know? For tangent, we know two things. What are those? Point 1, 3 is known and the slope is known. Slope is 2. Okay. Equation of tangent or equation of any line passing through x1, y1 and having slope m is nothing but y minus y1 is equal to m times x minus x1. I hope you remember this, right? Okay. And if you remember this well, then you can easily find the equation of tangent over here. What is that? Y minus 3 is equal to 2 times x minus 1. y minus y1 is equal to m times x minus x1. That's what we are doing. This is 2x that come, take the y on the right hand side. This becomes 2x minus y minus 2 plus 3. 3 minus 2 will be 1. This is equal to 0. This is equal to 0. Is that okay? Yes. That's for tangent. What about for normal? For normal, we remember that if two lines are perpendicular, this is m1, the slope is m1, this is slope m2, then the product of slopes will be equal to -1. That is something that we remember. So the slope of normal will be negative reciprocal of the slope of tangent, okay, or the negative reciprocal of this. So for normal, what do we have? For normal, the point is same. Point is 1, 3. Slope is equal to -1 upon that dy by dx, which is 2. That's what we have. Therefore, equation becomes y minus 3 is equal to, using the same idea, slope times x minus 1. Okay. 2y minus 6 is equal to minus x plus 1. This is what you get. And simplifying, x plus 2y minus 7 is equal to 0 is my answer for this question over here. That's a complete solution for this second part. Let's discuss the third part next. Y is equal to x power 3 at 1, 1. Now, y is equal to x power 3 is a pretty simple equation, and we can easily find the derivative of this. Dy by dx is equal to 3x power 2. And if you want to find at x equal to 1, dy by dx will be equal to what? This will be equal to simply 3. 3 times 1 square is 3. Now, the equation of tangent is pretty simple. For tangent, you have two things. What are the two things? You have point. Point is 1, 1. You have the slope. Slope, which is m, is equal to 3. Okay. And if you have point and slope, point x1, y1 and slope m, you can easily find the equation of line, which is y minus y1 is equal to m times x minus x1. This is how you find the equation of line, right? A pretty simple thing. Yes. So with the help of this, I can write y minus 1 is equal to m times x minus 1. This is what we have. What does that give me? This is 3x minus y minus 2 is equal to 0. That's my final answer for the equation of tangent. What about equation of normal? We can easily find normal as well. For normal, the slope will be negative reciprocal of the slope of tangent, right? Point is same, 1, 1. Slope is negative reciprocal. Reciprocal of this is what you get, right? Slope is known. Y minus 1 is equal to minus 1 upon 3. X minus 1 is what I get. This becomes 3y minus 3 is equal to minus x plus 1. Is that okay? Yes. This further becomes x plus 3y minus 4 is equal to 0. This is the equation of normal, as you can see over here. That's part third for you. Part fourth says y equals to x square at 0, 0. We're supposed to find equation of normal and tangent. Now, this y is equal to x square at 0, 0. This is a parabola, the standard parabola, and at 0, 0, the curve will be this. And can you easily find the equation of tangent and normal without doing any calculations? Maybe yes. At 0, 0, this is the curve y is equal to x square. So normal and tangent can be found easily. Do you observe that at 0, 0, this x-axis is the tangent. Tangent is x-axis, and the equation of this x-axis is simply y equals 0. And what about the normal? Normal is the line perpendicular to this tangent at this particular point, which is the y-axis. And the equation of y-axis is nothing but x equal to 0. This is the equation of normal. Now, this is something which we can note directly from the graph, but what about calculations? Let's do some calculations and prove that yes, this is the case. Let's follow the analytical approach, although we can observe this thing directly from here as well. But if you want to solve analytically, how do we do that? Let's take a look at this. Dy by dx is equal to 2x. X equal to 0 implies dy by dx will be simply equal to 0. Pretty simple, yes. Okay. So equation of tangent. For tangent, things will not be very difficult. For tangent, you can say that y minus 0, the point is known, is equal to 0 times x minus 0 is what I get. This tells me y equals 0 is the equation of tangent. The equation of tangent is simply y equals 0, and this is the x-axis basically. For normal, what do we do? For normal, you note that y minus 0 will be negative reciprocal of this 0. Oh, but you don't divide by 0. Don't worry about that too much. You don't divide by 0, but I can multiply by 0 over here, right or not? Yes. So, what I can do is, we don't divide by 0, that's okay. That's okay. But can we actually multiply by 0 without affecting anything too much? Yes. Maybe y minus 0 will be equal to something times x minus 0 minus 1 upon that slope of tangent. What is that? That's simply 0. I can do that, yes. And this tells me that x equal to 0 is the equation of normal, as you can see over here as well as over here using this approach. The only thing that will be an issue will be this division part, and I think you can take care of that with a simple idea, right? We say that it is the negative reciprocal, but for 0 you cannot take the reciprocal, so never mind. Instead of taking the reciprocal over here, simply take the denominator on this side and you are good to go with this. That's the equation of tangent and normal for this curve over here. The fifth part says x equals cos t, y equals sin t at t equals to pi by 4. Okay. The equation of curve is given in terms of parameters x and y in terms of t, and at t is equal to pi by 4 we are supposed to find the equation of tangent and normal. And how do we do that? Okay. So first thing that we are supposed to do is find the slope dy by dx. Now dy by dx in terms of parameter, when the values are given, will have to derivative with respect to t and this dy by dt on dx by dt. What is dy by dt? Derivative of y with respect to t, sin t derivative is simply cos t. Derivative of cos t is minus sin t, okay, and this becomes minus of cot t. Is that okay? Yes. At t equal to pi by 4, what does this become? At t equals pi by 4, comma, dy by dx will be equal to what? Cot pi by 4 is 1, therefore this will be equal to minus 1. That's the first thing that you note. But do you also understand one thing over here, that do you realize that at t is equal to pi by 4, you will have to find the points as well, right? So you don't directly have the points. At t equals to pi by 4, dy by dx is equal to this. X is equal to sin pi by 4, which is 1 upon root 2, and y will be equal to cos pi by 4, which is 1 upon root 2. And now I have the 2 points. Sorry, I have the point, right? This is x comma y, 1 by root 2 comma 1 by root 2. That's the point. Okay. So for tangent, what do I need? Point. Point is 1 by root 2 comma 1 by root 2. Okay. Slope is equal to minus 1. This is the point and this is the slope. I can easily find that equation after that. For normal, what do I need? I need again 2 things. What are those 2 things? Similar things. Again, I have the point, the same point, 1 by root 2 comma 1 by root 2, and I have the slope. Slope is negative reciprocal of this. Okay, this is minus 1. Minus 1 upon this expression is what I'll need. Minus 1 upon minus 1, which is plus 1. That's the slope of this particular normal. Now, finding the equation will not be difficult. Equation will be y minus 1 by root 2 is equal to slope times x minus x1, which is 1 upon root 2. This is what I get. Right? Minus x will come over here, and what will this give me? X plus y minus 1 by root 2, and this becomes minus 1 by root 2 again. Is it? Yes. This becomes minus 2 by root 2. This is minus root 2 will be equal to 0. That's the equation of tangent. What about equation of normal? You will write y minus 1 by root 2 is equal to x 1 times x minus 1 by root 2, and this will give me y equals x, or you can write it as x minus y is equal to 0. That's the equation of normal for this equation over here. That's a complete solution that is required.